7.3, quadratic like equations. We spent a lot of time earlier on figuring out how to deal with quadratics. We have quadratic formula, we have factoring, we have completing the square, we have a bunch of different things. And so what this idea is about is simply really just opening up to some broader kinds of options available to us. So let me remind you about a quadratic. Here's a real simple one. If I wanted to factor this, if a quadratic factors, it factors into two binomials, and so the options for the x squared are going to be x times x, and the options to get the 36 at the end are going to be 3 times 12. There's also 4 times 9, but I noticed that the 3 and the 12 can get me 15 in the middle. So there you go. There's the factors of that. That's all that question would be. This doesn't have an equation. There's no equals, so you're not going to solve this. But now notice something here. Notice the relationship, or the similarities rather, between these two expressions. Notice something about quadratics. If you take this term and you square it, you get that term. Notice here, if I take this term and I square it, I get, well, x squared squared is x to the fourth. I get that term. This is what's known as quadratic like. So I'm going to do a little playing around with this and do a substitution that is going to allow me to figure out how to solve, or rather factor, this polynomial. Because it's not a quadratic. Quadratics are raised to the second power. This one's raised to the fourth power. But remember what I noticed before, that when I take this thing and square it, I get that term. Likewise here, when I square this one, I get that one. So I'm going to let w equal x squared. And I'm going to take this equation. Now, remember we figured out a moment ago that x squared squared was x to the fourth. And, well, there's that x squared. I'm going to take both of these x squareds out. And when I do that, I'm going to replace them with what I said x squared was equal to, which was w. Now what I've created is, in fact, a quadratic. Now the hardest thing, I don't know if it's the hardest thing, the biggest thing you got to do here is to remember that you have to solve this problem for x. In a minute, I'm going to, factor it. In a minute, I'm going to deal with this in terms of w, and I got to get back to the x eventually. So next step here is to figure out the factors. So this is going to factor just like the original one did, w minus 3 and w minus 12. At the end, then, I would replace these guys with what those are equal to. So I'm going to take out the w, and in their place, I'm going to put in x squared and x squared. Now, neither of these can be factored nicely, so you would just stop right here. If this was, for example, let me change the problem just for a moment. What if that had been a 4 instead? Then x squared minus 4 factors is x plus 2 and x minus 2. But where the problem originally was, that wouldn't factor, and so you'd be done. But let me do a variation on the theme. What if at the very beginning this had been equal to 0? Now the question would be to solve as opposed to just factor. But you got to get to that event. You got to get to solving by way of factoring. So I get to the same place. I do this substitution. I take out the x squared and I put in the w into there. W minus 3 equals to 12, and I'm sorry, said that wrong. W minus 3 is equal to 0, and w minus 12 is equal to 0. Solve both those equations for w, and replace them. And in the equation then, when I replace the w with the x squared, so that instead of, let me back up and show you there, instead of that being w minus 3 equals 0, now it's x squared minus 3 equals 0. Add the 3 to the other side, and of course to solve that you take a square root. Don't forget about the plus and minus. Got a little chopped off at the bottom there, sorry. Likewise, add 12, square root on both sides. Take square root of 12. Remember 12 is 4 times 3, so square root of 4 comes out as 2. square root of 3. Don't forget the plus or minus. And so those would be the solutions. There'd be 4 of them. Interestingly enough, this was raised to the 4th power. So let's look at another variation on a theme. You remember back at the very beginning, I said, notice how when you take this term, the variable, and you square it, you get the original one. When I take x to the 1/3 and I square it, I get x to the 2/3, which is what you have here. That's how you know that you can do this process, that it's a quadratic-like equation, even though it's not actually a quadratic. So I'm going to let the w equal this middle term. So let w equal that middle term, and then I'm going to take this x to the 1/3 and replace it with w, and this was x to the 1/3 squared, and that's what this term is, so I'm going to replace the x to the 1/3 with w's. W in there and a w in there, and then factor it. Now this is an equation, so I'm trying to solve the equation. Well, let me back up, make sure we didn't get lost. I factored it, right? Take each one of the factors, set them equal to 0, and solve. But keep in mind, I'm not solving for w, I'm solving for the original problem, which was x. So I replace the w, notice what's happening here, I replace that w with what it was equal to. Now, to get rid of the 1/3, I'm going to raise both sides to the 3rd power. That's how I get this step. And 1/3 raised to the 3rd power is just x to the 1st. 5 to the 3rd power, 125. Over here, again, those guys, that's a 3. Those guys cancel each other out, undo each other, get you x to the 1st, and you get 1. And there's your solutions. And you can put a smiley face. Hopefully that helps. Come talk to me if you have some additional questions.